Oh yeah, you had started recording before.
I thought
I
so.
don't
I
know.
don't.
Yeah,
Oh,
the thing that prompt propped up.
okay, so we're recording again. We'll see what happens with this. All right, I'm now going to share my screen. We're going to take a look at 16.1. And this is a simple problem with the num1 and num2 being entered by the user. And again, I see an example of a try block. Now, this try block only has 2 lines in it. It says quotient equals divide num1, num2, and see out the quotient is da 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 da. And I have a catch block. And you notice the way this catch is written kind of looks a little bit like a function, but it's not. But what I mean by that is it has an argument list. It has a string coming in, and it's called an exception string, which is just a variable name that we're using. So I don't see much going on here because remember I said if I'm going to catch, I need to throw it. But now if I jump down to the function divide, I see in divide where if that denominator is in fact 0, I'm going to create a string name and I'm going to throw that. And when I throw it, it's going to get ready and it's going to land in the catch block. So I'm throwing a string. The string now becomes my error message, my object. It's my whatever it is I'm throwing. So I throw this string. It goes back up. It's caught in line 25 and a simple message is displayed. Okay, so that's just a simple example. Now we're going to go a little bit more in depth. So I want you to go to version 1 of Rectangle and load it up. Okay, so let's start with the header file of Rectangle. And I come in and I notice something new, and that starts on line 12. And even though in line 5 I
We're
declare,
looking at File Explorer, by the way.
what's that?
Looking
You're
at File
sharing.
Explorer.
Stop share. And still recording. I come into here. We have a nightmare going on right now. Technology is its finest. Share screen. Screen sharing has stopped. What is going on? One more try.
The machines are finally starting to rebel.
Yes. All right. Did you get it yet now?
Yeah, we see it now.
Okay. And you should have it in front of you. So we're taking a look at the header file. And in lines 12 and 13, I see a class inside of a class. When you take CPS 230, you'll start using words like inner class and some different things because we talk about classes a lot of different ways. But I see this class called negative size, and it's nothing. It's just an empty definition. So we're taking baby steps, okay? Baby steps, Bob. So I have this class called negative size. Now, if I go into rectangle.cpp, I see in lines 13 and lines 25, I am throwing a what?
An instance of negative size.
Excellent. An instance of negative size, right? So I'm kind of throwing an object of negative size, which basically goes over to negative size class. So if I go into my program, and again, if I enter the length or enter the width, and it goes back to if it's less than 0, I'm going to throw a negative size, which is going to go back to my header file, which is now going to land in this empty class. So that's just baby steps of how I can throw not a string, but I can throw an instance of this negative size class, and then maybe something can happen from there. So what I want you to do now is go to load up version 2. Can you see my version 2?
No, you're at your file explorer.
All right. I don't know why that keeps popping up, my file explorer. Okay. Close that. Now I think I have it right.
Is 16.3 and 16.4 part of it?
Right. I just wanted you to
Okay.
put up 16.3 right there. Look, we're looking at the header file right now. And instead of having one class that's going to catch an exception, I can actually have a second one or a third one. I can have multiple ones. This time I'm setting up a class called negative width. This one I'm calling, the second one I'm calling negative length. So depending on which type of error it is, I can instantiate different types of objects. Again, this one, this spec file doesn't have much, or the implementation file doesn't have much in it. Same kind of thing. I'm just throwing that simple error. And in 16.3, I have my try block. And you notice this time, I have two different catch blocks, okay? So now, if an error is thrown of type negative width, it needs to be caught somewhere. And this time, I'm going to specify which class is being caught. If you look at line 28, I'm catching the negative width one here. You notice the SRO, the double colons, and the name of the class rectangle, so I know where this class is when I catch it. Same thing in line 33. If it's a rectangle, it's the negative length class. It's going to be caught here. Well, let's take a quick look at 16.4. And this time, when I have my catch, I have them separated out. I have the catch for the negative width, and if it happens to be a negative width, I catch it right away. I have a message that goes along with it. And then you notice what happens after line 34. Instead of my program ending after the catch block, it's going to take me back up to 20 and let me try again. So normally when you get an exception error, a program's going to end. But we can write our programs so that if I do get one of these exception errors, it'll stay inside of a loop and continue to work. So once again, I come in, I have try again, I get to my try block, my rectangle.setWidth. It's going to go over to my implementation file. If it's negative, I throw that error. It's created right now in my rectangle class, and the class is called negative width. So it's catching an object, which we're going to go a little bit farther after that. So it knows to come into this catch block. Okay. Now that negative width, we may be adding more stuff up there in a moment. You're going to see what happens when we move on to the next version. But otherwise, it's going to come in here and say, please enter a non-negative number, CN width, and then it's going to loop back around. Questions on 16.3 or 16.4? So 16.4 is just letting me recover from bad data. Okay, so now next one we're going to take a look at is actually when I instantiate the object of that class, something good's going to happen. So go ahead and load up version, where are we, version 3? Make sure it works. All right, so now I'm going to take a look at the header file, and I'm going to take a look at my definition for my class negative width. And now this time it's starting to become a little bit more of a class. This time I have a field called value. I have in line 17 a constructor, so that when I do an instance of this class, I'm going to have a constructor where a value is coming over, and inside of the class value is going to get that val. And then I have an accessor method called getVal that's actually going to return what that bad value was. And if you look at negative length, I have the same kind of thing as well. So if I go to 16.5, I come in and I hit my try block, and I go to set the width and set the length. And when I do set width, if it's a negative, it's going to throw an instance of the negative width class. So at line 28, I'm going to catch that negative width class that's in rectangle, and I have an object called E that's coming over. And they call it E, you see E commonly because of it's an exception. We could have called it anything we want, but it's E. And in line 30, I'm going back to the negative width class using that accessor method to see what that invalid value was. So I could really get into building a lot of things in the negative width exception class that I put in rectangle, so that again, I'm getting this object E, and if I have a lot of functions, I could work with it, manipulate it, do different things. Questions? Okay, what I'm going to have you do now on your own, I'm not going to put you in pairs. Now maybe I will put you in pairs because I want it to go a little bit quicker. I want you to add to this version, this program right here. I want you to include 2 more. So if I go back to here, I have 2 exception classes, one for negative width, one for negative length.
We can't see anything on your screen.
Okay, let me go back, share screen. Can you see it now?
Yeah.
Okay, maybe I'm going too fast for Zoom. So back in your header file, line 12, you have a class negative width. In line 25, you have an exception class called negative length. I'd like you to add and test 2 more exception classes. One, if I have an error where my area that I calculate is greater than 100. Let's just do that one. So I want you to have another situation where I'm going to calculate the area. And if when I calculate it, it's greater than 100, I'd like you to throw an exception. So you're going to create a new class here. Does everybody understand what we're saying?
Okay. And then we're going to have a try catch, right?
Yes.
Okay.
Yep. And add it to your demo. Okay. Any questions on what we just finished up? Once again, that was an introduction to how exceptions work, and they go much, much deeper. And in 230, when you get into heavy object-oriented talking about classes, you start to see about parent classes and child classes and the super class, subclass relationship and how they inherit things from each other. And it really builds on how I can write some of these exceptions. The next section in this chapter talks about function templates. And these are kind of nice, where I don't necessarily have to overload some templates because of different data types like int or double. I can just write one and be done. I can write a generic one. So if you look here on the left side of my page, I say int square and I have a number and I want to square the number. But what if I wanted to, well, not just square an int, but what if I wanted this to be a double? and, return a double? What if I wanted it to be, something else? Well, I'd have to keep writing more and more of the same functions, kind of overloading it, but it's not really a much different parameter list. Well, what I can do instead is write something that looks like this: template class T, where T is going to be the data type of what is listed here, whatever parameter is coming in. Okay, so template T, and then everything else is the same as over here, except I replace the word int with T. So if I declare this, it's kind of nice because this template function that I wrote can be used for any type of data. Well, what I'd like you to do now is go and load up 16.7, 16.8, 9, and 10. All four of those. 16.7, 8, 9, and 10. Excuse me. All right, starting with 16.7. This is an example right away of the one we were just talking about. In line 7, I have template class T. I'm creating a function called square. My return type is whatever the T is, and my parameter list includes one variable that is T. And if you look below, I have a user enter an integer and a double, and then I display both of their squares. Kind of neat, kind of short, fairly simple. Questions? 16.8. Well, sometimes I may want to mess around, and what if I want to have more than one parameter in my parameter list? Well, if you take a look at 5, line 5, template class T, you notice the return type is a void. Doesn't have to be the same as the rest. And I have two variables of type T. And what I wrote here was a nice generic swap. So I can swap integers, swap doubles. I can swap, wonder if I could swap strings. I'd have to add some code down below. But it's a generic swap. Notice how I have the reference variables to return the two different variables. Okay, questions? 16.9. What do I have going on here? I have a template. I have class T1 and class T2. Well, this time I have two different variables in my parameter list. One could be int, one could be double, both could be ints. I have different things that I could put in there. So I'm having two coming in. I'm checking the size of. Does anybody know what size of checks for? The number
How
of.
many bytes are
Yeah.
used to store it?
Right, the number of bytes used. And if you look below, that comes out, we're comparing an int and a double, and we see which one takes up the most memory. The next one is a char and a float. Which one takes up the most memory? Well, we know a char is only 2 bytes and an integer is 4. What's a double? Is a double 8? If you ran that program, what's a double? Does the program run? Nobody like me. Everybody eating their toast.
A bagel.
A bagel.
Say bites.
8. That's what I thought it was. Just double checking. All right. 1610. I pull up. This time I have something a little bit different. What's going on in this guy? What's the name of my first template function?
Awesome.
It's sum, right? What's the name of my second one? Sum. What's actually happening here with these two functions? They are
You're overloading it.
overloaded, right? They have different signatures. The parameter lists are different. So I can do quite a bit with template functions, and we're really only hitting the tip of the iceberg with all the stuff that we can do. All right, I'm going to throw you back into your groups because you seem to be excited about that. And you're going to go and take a look at page 1026, number 3. And I want you to write templates for max and min. Okay, the min should accept 2 arguments, find out what's the lesser, and the max should 2 arguments, find out what's the greater, put a driver program in.
Is this in the Gladys or the Nighthawk book?
This is in the Gaddis book,
Thank you.
page 1026, the min and max templates. Write templates for 2 functions. The min function should accept 2 arguments and return the values that's the lowest. The max should accept 2 arguments and return the greatest. Questions? I'm going to put you back into your breakout rooms. When you are done, we are done. And have a good weekend. Call me if you need help. I'll be around.
Thanks.